So as we are entering Phenotype February week 3, first what we want to start with is reflect on how week 2 went. So what we were doing on, let me move it so that you don't see yourselves. So what we've been doing so far is during week 1, we've been writing clinical descriptions and for all of the phenotypes that people want to study in their studies. And in week 2, we were translating those clinical descriptions into the concept sets and logic so that we create cohort definitions. Now, to remind you, during the week 1, we wrote clinical descriptions for 10 studies, and we identified 200 phenotypes to create, with 63 phenotypes available in the phenotype library already, which of course helped us a lot. And over the week 2, we were translating this work into creating the cohort definitions. And we had a very intense week with 2 office hours and more than 7 individual consultations. And as I talk, I really represent a broader group who works in the Phenotype February, who put a lot of effort into supporting the community. So I want to pause here to say a specific thank to Azza, Patrick, Gowtham, and Lana for making this happen. And that's been a lot of work and a lot of fun. And we've seen that the community is really engaged with us on translating their ideas into the cohort definitions. And before we go into some numbers, we first want to share a couple of lessons from week 2. And there are more lessons, but we wanted to focus on a couple of them. So the first lesson was that when you work on the concept sets, you want to check the included concepts and you want to look at the recommendations. For example, what you see in front of you is the concept set for sarcoidosis that was created a week ago. And if you look at the concept set expression on the bottom, you see that there are 6 terms without descendants, such as sarcoid type granulomas, no necrotizing granulomatosis inflammation, and so on and so forth. But if you look at the included concepts, you in fact would see here the list of the SNOMED and OXMIS terms that are included as source codes into this concept set. And on your left side, you can see in the vocabularies that there are no ICD-10 or ICD-9 codes, which we commonly look at. So that already can make you suspicious about this concept set, or can highlight an opportunity to improve, because right now, none of the ICD-10s or ICD-9s are captured through this concept set. Moreover, if we were to look at the recommendations in this recommend tab, we would see that there are some terms that look very much like sarcoidosis. For example, the second term that gets recommended by Phoebe quite literally says sarcoidosis, and it has 9 million patients loaded on it or on its descendants. So if you were to check both of these tabs, that will already give you an opportunity to refine this concept set. And this is what the team did. They went ahead and they've done a wonderful job with looking through the relevant terms, looking through the included concepts, and they expanded their concept set to now 21 concepts with the descendants of various degrees of granularity, from the third term sarcoidosis all the way down to more detailed terms like dilated cardiomyopathy due to sarcoidosis. And now, if we were to look into the included source codes here in the middle of the page, you would see that now this concept set includes 30 ICD-10 CM codes and 29 ICD-9 CM codes. And the recommended tab, in fact, does not recommend anything that is relevant anymore. So that shows a very nice work of the team who took what we recommended in terms of reviewing the source codes and the recommendations and iterated heavily over the concept set and brought it all the way to a very nice comprehensive concept set. Now you may wonder, how did I check it out? Well, Atlas has this very nice functionality of looking through versions. There is this tab in the middle of your screen, you can see it, called versions. And there you can check out different versions of a cohort, preview them, or even create a copy. And you can see how hard the team has been working on this, because there's been 44 versions of this cohort. So way to go. Now, the second lesson is not about the concept sets, but about your inclusion criteria and the timeframes. What you're looking at here is a cohort that looks for patients who start on methotrexate for the first time in patient history. So they're really looking for the incident users of methotrexate. But now they also have an inclusion criteria that says no prior demerits exposure. And the very first criterion in that group is exactly 0 exposures to methotrexate all days before to 0 days before. Now, because it says 0 days before, it is inclusive of the day 0 or the index date. So what we are doing in this cohort is we are simultaneously asking for people to start methotrexate on day 0, but then excluding patients who had methotrexate on the day 0. So when we saw it, we right away knew that this cohort will get 0 counts. And in fact, the study authors could see the same thing for themselves, because in the tab with the execution, you could see that all of the counts for all of the data sources in public atlas have zeros. Now, if you don't have data, this is why we encourage you to work with other participants in your study groups, because then they will have data and you'll be able to see the problems with your cohorts early based on the counts. And also moving on with the looking at the counts early, what we found is that it's really useful to look at the cohort counts early, because this is the first indicator of whether you're getting the patients you want. In this example, this cohort focused on patients with biologic therapy who had malignant melanoma before. And then the cohort had multiple inclusion and exclusion criteria because the study team thought really, really hard about the patients that they want to get. So they spent a lot of time on perfecting those criteria, on making sure that they match their descriptions, match their study intent. But then if you look at the patient counts, for example, here in one of the data sources we have in our disposal, OptimHR plus Enric Oncology, you'll see that this definition only retrieves 54 patients, which means that it will be very hard to make any sort of inference from this cohort. And it also provides you the drop down of the criteria and what kind of impact those criteria had on your patient counts. So now you can go back and revise those criteria to increase your sample size. So that was the number 3 learning. And as we worked together, we will now open the floor to other participants and study leads to provide their feedback. Before they do that, I just want to mention that all of this work has resulted just during 4 days, resulted into 177 cohort definitions created. And you can see that a lot of them are exposures, but also the study leads and the teams created a lot of indications and outcomes. And we were able to use those cohort definitions to run cohort diagnostics for 91 cohorts, mostly indications, and the outcomes on 5 databases. So over the next 2 weeks, what we are going to do is we are going to use this cohort diagnostics to look at the cohorts and iterate over them to make better cohorts that match the intent. And with this sneak peek of what we are going to do, I will now open the floor to the study participants and also Azza, Gowtham, and Patrick and Lana to reflect on what they learned.
Yeah, no, I think we have learned a lot, Anna, and just like you, we all share this passion of phenotyping. I have several reflections just observing, working with this large group of people on this 177 cohort definitions. One of the fundamental ideas that we introduced is let's agree on the clinical idea that we want to phenotype. And to do that, we said, let's build a tool, and tool we call it as clinical description. But then it's onerous to write this long clinical description, so we used a Gen AI prompt to help write it. But then we realized in this that one prompt is not sufficient, because the prompt that we have in our public domain is all centered around a pharmacovigilance use case, and that didn't help us in many of the studies. So we were reflecting about, for example, when the osteoporosis, when you and I were working on it, what is a fragility fracture? Should patients less than 50 who have a trauma and a fracture be excluded? And we were there talking about how we could build multiple prompts, and that prompt could be intelligent enough that it selects the prompt that is best suited based on the study's use case. And then it even recommends to the investigator, how about this or how about that? And if they select one option, it adds that to the documentation. So I think we have a lot of work to do in terms of aligning on what the target clinical idea is. And we had similar discussions with diabetes. How about the lab results and so on and so forth. One of our fundamental ideas is also to do a systematic literature search before building core definitions. And in the 177 core definitions, we did not even do a single literature search because it takes time. It takes 2 weeks or 3 weeks to do literature search on one clinical idea. Forget 177 definitions. And I think the office hours, I felt like the office hours was a great team building collaborative environment where folks from the community could ask the more experienced phenotypers. I love the way you handle the issue with the SPL vocabulary, for example. In one of our collaborators used SPL as a classification concept to build a concept set on medications. But then SPL looks good. It's called classification, but it is not really supported in the OMA vocabulary. We recommend the use of ATCs and RxNow, and that education, that nugget of information, sharing that with the community was very useful. I maintain the Odyssey Phenotype Library, and I love to see the use of the Odyssey Phenotype Library, but then, man, it is hard to use. There is no user interface. There's no way to retrieve definitions. It's hard to look at the documentation. I've been giving people Excel spreadsheets here and there to help them identify it, and they all used it. But we need a better way. We need to improve and clean up the library so that it is more usable. It was used. It's just not usable, but it was used, which is excellent. And I think the other one was I was thinking about, we try to separate the analytic study versus the phenotyping as much as possible, but the overlap is inevitable. We need to always think about the study when we phenotype, even though we try to separate the two. With Michelle's study, she was thinking about utilization of diabetic screening, retinopathy screening by calendar year. And one of the questions, I think, was, should we build core definitions by calendar year? Well, is this a core definition challenge, or is it an analytic function challenge? So where do we solve this problem? And I've had several reflections on this just this last 2 weeks. So excited to work with you all.
We would really like to hear from study leads. I don't see hands up, but maybe while you gather your thoughts, I'll share one little learning that I think of as a very, very low-hanging fruit that we can work on. There were many exposure cohorts that we needed to create because there's were a lot of treatment pathway questions and a lot of exposures, including procedures. And I found a few common mistakes that people do as they create cohorts for exposures, including, do we take all events or earliest events? What's the right persistent window? What is a surveillance window? What are these 3 different things in Atlas that we need to pick? And there were many common misuse of those. Out of our experience of many years of building exposure cohorts, we found that we actually have a shell for an exposure cohort in Atlas, where you most likely need all events, need to think of the surveillance and persistent window in a certain way. And I think as a phenotype working group, we can come up and standardize that template from Atlas and make it available for people. And instead of people starting from scratch every time they want to build an exposure cohort, we can give them that template and explain what are the 3 things they need to make a design choice on and how to do that. Instead of people navigating, do we take all event or earliest event? Where do we put our exclusions? What is a look back period? We can create those and explain what that shell looks like and put it in the library and ask people just to use it and edit it instead of always starting from scratch. Okay, I see Cindy, I see others. Please share your experiences. Go ahead.
Oh, sure. I think I always learn something new every project that I do, and I'm always impressed and, confused by the mapping that happens in the CDM from non-standard to standard vocabulary. Because I think big data researchers, certainly some of us in the eye care vision research work group, were more accustomed to thinking about source concepts. So I had created this really complicated definition for what it means to have an in-office diabetic retinopathy screening, thinking about ICD codes and CPT codes. And, Brian Toy, recommended one, a Z code that was used in Cerner. But when we looked at how the mapping happens into a standard vocabulary, it got mapped to a very generic eye and ear screening code that was too generic to really use. And so I think, working with Azza and just looking at the process of just, forget maybe a little bit, kind of forget about the source concepts and just go straight to the standard concepts, working with the concept sets and Atlas is helpful.
Yesenia, so Asieh's hands, yeah.
Okay, I'm gonna just tell you guys a little bit about what we have been up to. A lot of the challenges, the stuff that Gowtham brought up, it's a general challenge that everyone is facing. And what do we start with and what do we do? And in our case, those who have been on the call when we pitched the idea was to basically go through the guideline for metastatic, muscle-invasive and metastatic bladder cancer, the 2024 EAU guideline. And instead of jumping to one specific question, we first decided, because it's hard and there's so many decisions that are happening to get to a specific point. And instead of jumping to one question, we decided to do a systematic assessment of assessing the attributes of each node. What does it take to identify patient population or phenotypes within each decision, treatment, or any types of clinical decision? Once we identify that, we can turn it into concept sets and cohorts. And after that, we can map the available, go to our data partners. We can see basically through the CohortDiagnostics and all the other tools that are available, do we have the data? Are there things that we need to improve? And we know we're working in the field of oncology, a lot of things can happen, right? And once we have a good understanding, we map them to the gaps that are identified by the guideline group. We can certainly with confidence say that which of the gaps we can reliably answer with the data that we have access to within the community. But to do that, we have to start with something. We're focusing on metastatic bladder cancer. So we started by defining a very general definition with the idea that this can give us a lot of information just on the first step. Can we identify metastatic bladder cancer? There are a lot of craziness that happens, and we've seen it in the data in terms of how the diagnosis of metastases and the disease happens and the logic behind that. So our goal and what we've proposed is let's start to understand, can we identify what are the things that we know, what could have gone wrong in terms of our concept sets, what could be a data problem, how can we work with the data partner? Is it going to be our final definition? Definitely not. Do we need to add additional criteria? Yes. And we also have to improve. So that's our approach right now. We're going to build a lot more phenotypes, but the first one was set up in a way to help us understand what is it that we're dealing with as we're defining all the attributes we're going to add to that. So I really appreciate for all the works and everyone who has been volunteered. Please consider joining us.
Thank you, Asieh. I see Evan.
I just wanted to make sure that that you guys and the people that were helping out get a proper round of appreciation from us. That was a ton of work. I know that I could see even on the spreadsheet that everybody's weekend was ending and yours was just starting, and so I know there was probably a lot of work that happened over the weekend. And the other thing I noticed, that demo atlas that took a beating. Like, I don't know what kind of changes have happened But that was the best performance of an Atlas instance that I've seen. I was like, this thing is not going to make it through this week, and it did great. And so, maybe I don't know if it's Lee Evans or maybe somebody can kind of point to where that congratulations should go. But that's a massive asset for the community to have a stable platform like that. Like, you would finish a cohort and there'd be 30 more that were in there by the time you started on your next one. So it was an impressive performance there as well.
And I wanted to thank the vocabulary team and Claire for making the record counts available from the Odyssey Network study. That was phenomenal resource that was added to this Atlas instance.
Okay, and then we have 1 minute. I know we have thought about going for, so let's cover next step. And tomorrow we will do the demo of CohortDiagnostics for people to be able to learn things from CohortDiagnostics. We'll do this in the office hours tomorrow.
And the session will be recorded if you cannot make it, but please come. You can find the meeting in the Phenotype Development Work Group in the meetings.
And Gowtham, can you share the link where CohortDiagnostics Shiny has the 90 cohorts?
Yeah, so it's on. It is currently on data.odyssey.org, but will be ported to results.odyssey.org to ensure stability. And as soon as that happens, I will share it.
Okay, so study leads will start the next week tomorrow with a demo of CohortDiagnostics. If you already know how to use CohortDiagnostics, go ahead. Once we share it, you can also go ahead and evaluate your cohort. If you have never seen CohortDiagnostics and don't have any members of your team who know how to do that, make sure you attend tomorrow's call. We're gonna go through Anna's cohort as an exemplar, and you can all follow, and we're happy to also answer questions and help you through. If you still need CohortDiagnostics for a cohort that didn't go in the first run, we're also going to run another one. Just make sure to use the tracker to reflect that information. Okay.
Awesome.
See everyone tomorrow.
Great. Thank you, team, for all of your hard work, and to the community for making great progress on these studies. I really look forward to continuing through Phenotype February and seeing these studies move forward. So thank you all very much. Have a great week and a great evening, and we'll talk to you all soon. See you next week. Bye.
Thanks, bye.